Solid is obtained by revolving the shaded portion. So we have this shaded portion in the diagram. Region about a specific line, and they're saying specific line is x-axis. Sketch the solid. So first of all, we need to sketch the solid. Our method of sketching is the curve here is this curve. Try to draw the mirror image of this curve in the line of rotation. The line of rotation is x-axis here. So I try to draw a mirror image of the whole region in the thing. And I am going to draw a circular shape here to show that this is a rotation. So this is my solid of rotation. If you can imagine a rotation on each point, that's why the circle is representing. So rotation is happening around x-axis. Now a typical or a disc washer method is used to find the volume as an integral. Okay, so how you do that is perpendicular to the axis of rotation. Axis of rotation was x-axis. Perpendicular to that, you cut the solid like a saw, and you see that the cross section is gonna be a circular shape. So that's gonna be a disc in this case, not washer, right? And then that is area of cross section. You find the radius of that. The radius, if this point here is on the curve xy, then the radius is y coordinate, which is given by x squared plus 5. Okay. Now, volume is A to B, area of the cross section with respect to x, or in this case, the area is of the disk, therefore pi times radius square. Radius in this case will be becoming the function itself from A to B with respect to x. Therefore, we set up the integral as volume is x value is from 0 to 3. So from 0 to 3, pi times f of x, which is x squared plus 5 whole square dx. So this part is the area of your disk which we cut using the cross section, because the radius of that disk is coming from y value, which is f of x. So pi times square of x squared plus 5. Pi can be factored out. This square can be opened as x4 plus 10x square plus 25 using binomial square. Pi is outside. Integral of x4 would be x5 by 5, 10x cubed by 3 plus 25x. Okay. Once you hit the integral, you need to write the limits on the right hand side using definite integrals. Now we put the upper limit first in the function minus the lower limit. When we put limit, it will be 3 to the power 5 by 5 plus 10 times 3 cubed by 3 plus 25 times 3. And when you put 0, everything will be just 0. Now you can put it all in the calculator and you will get 1068 by 5 pi. That is the volume of the solid obtained by rotating that given region about x-axis. Let's practice one more. A solid is obtained by revolving this shaded portion. The shaded portion is given in the question about the specific line, and the specific line is given as y-axis. Sketch the solid first and use a typical disk or washer method to set up an integral for the volume of solid. Our axis of rotation here is y-axis. You can draw a little rotation to show that. So a way of drawing that solid is draw the mirror image of this shape over y-axis. Okay, so let's try to draw. I drew the mirror image, and to show the rotation, you're going to draw a little circle here. So this is your solid of rotation basically, right? Now, once you have solid of rotation, we're going to use either disk or washer method. So perpendicular to the axis of rotation. Axis of rotation here is y-axis. Perpendicular to that, you're gonna cut it like with a plane surface and see what is your cross section. Your cross section in this case is gonna be a circle. Let's figure out what is the radius of this circle. If this point is on the curve xy, the horizontal distance is x. Therefore, the radius of your disk is x. But we know y is equal to x cubed plus 1. So how do you find x from there? Y minus 1 equal to x cubed. X would be equal to cube root of y minus 1. So therefore, the radius of your disk is coming as x, which is cube root of y minus 1. So what will be the area of the disk? That will be pi times radius square. Therefore, pi times cube root of y minus 1 whole square. Basically, pi times y minus 1 the power 2 by 3. So, what is the volume? Volume is integral from A to B. Because the rotation is in terms of y, so the function is going to be integrated with respect to y. So therefore, the limits have to be the y values. The y values are going from 1 to, it's given 9 here. So therefore, our integral is 1 to 9. And this portion here is area of your disk in terms of y. And that I found it as this one. So pi comes out y minus 1 the power 2 by 3 with respect to y, because area of your disk is coming to be pi times radius square. Okay, so what is the integral of this? Pi out. This can be done using simple power rule because the coefficient of y is 1. 2 by 3 plus 1 is going to be 5 by 3 divided by 5 by 3 from 1 to 9. And we put the limits. Pi is outside. We put the upper limit minus the lower limit. And this 5 by 3 is going to flip and come out with pi. So what do we have? 9 minus 1 power 5 by 3 and 1 minus 1 power 5 by 3. 1 minus 1 is going to just become 0. So we don't need to worry about that. We have is 3 pi by 5 times 8 power 5 by 3. That's going to be 3 pi by 5. Sorry, 3 pi by 5 times 8 power 1/3 is 2. 2 power 5 is 32. Basically, we have the volume as 96 pi by 5 of the given solid. So the process is try to draw the solid. Think of what your axis of rotation is. Axis of rotation was y-axis. So try to draw the mirror image of the region in y-axis. And then perpendicular to the axis of rotation. That means because axis of rotation is vertical, then cut horizontally and see what is your cross section. Your cross section was coming as a disk. Find the radius of that disk that was coming as x coordinate. Therefore, because your axis of rotation is y, therefore integral will be in terms of y. Area of the disk, ay, integrated with respect to y. And then we just have simple integral.